Hi, this is Bill Punch. This video is one of a series of videos used to support Michigan State University's Introduction to Computer Science using Python CSE 231. This is round 2 of our introduction to our second control statement, the while statement. Let's get started. So one of the odd things about the while statement is, as weird as it may sound, a while statement can have an else clause associated with it. What the heck does an else clause mean? Well, if we look at a diagram again of our sort of flow of our process through the while statement, we have what we had before: statement, statement, statement. We hit the Boolean expression. As long as this expression is true, we're going to loop through the while suite until the Boolean becomes false. However, now if we have an else suite associated at the end of the while loop, on the way out of the while loop, we will execute a series of statements in the else suite, and then at that point we'll pick up executing the remaining Python statements. So we execute the else statement when the Boolean becomes false. It's a series of statements that we execute on the way out of the loop, essentially. It's not a well-named clause, else. We're not doing something or something else. We're simply doing something on the way out of the loop. And it really makes a little more sense to talk about the else statement when we talk about the else statement in the context of some extra loop control statements we have available to us. So let's take a look at those very quickly. The first loop control statement is the break statement. A break statement, when executed in the context of the loop, will do two things. We break out of all of the remaining loop statements, we quit the loop essentially, and we skip the else. So when we hit a break statement in a loop, we exit the loop, we exit everything that was going on in the loop, but we skip the else. And so the statements that we execute on the way out, we skip. The other one is called the continue statement. When we hit a continue statement in the loop for that particular iteration, so the loop continues, but that particular iteration ends, we stop that iteration, we skip any remaining lines in the while suite, and we go straight to the top of the loop and reevaluate the Boolean. So one way to look at these things is to use a piece of code called pseudocode. So this is code that's not exactly executable, but it gives us some English language combination with Python to give us an idea of what's going to happen. So we have three Booleans in this expression. The Boolean 1, which is the while Boolean, and then we have two if statements, Boolean 2 and Boolean 3. First thing I want you to notice is that all of this is indented to the same level under the while loop. So this is all the while suite. But the stuff underneath the if statements, there's a if suite here and another if suite there. And this is particular to that if statement. This suite is particular to that if statement. We have an else suite. And notice that the else is at the same indentation level as the while. These are two parts of the same thing. That's sort of our structural layout. Let's examine how this thing might run. So let's imagine we come in. Boolean 1 comes out true. We execute this statement, we execute this statement, and then we evaluate the Boolean. What happens if this Boolean is true as well? We break. That means we skip everything that remains. We also skip the else suite. We jump directly to whatever comes after the while, the print statement. Let's do it again. What happens if the Boolean 1 is true? We execute this statement, we execute this statement. This Boolean comes out false, so we skip it. This Boolean comes out true. Continue means skip these statements, go straight back to the top of the Boolean, and reevaluate before we go on. Where would we use these kinds of ideas? Let's look at a simple example. This is a test for prime numbers. We have some input number, the number 11, and we create an integer divisor that's one less than the original number. And what we do is we loop through this series of statements where we reduce the integer divisor by 1 every time until it becomes 1. And we look, and remember this operator, this is the remainder operator, yes? And so we take our original number and we divide it by our divisor, and we look to see if the remainder is 0. And if the remainder is 0, then it's evenly divisible, and that particular divisor is a factor. And we're looking for numbers that have no factors except themselves in 1. So when we find a factor, we print that we found the factor, and then we break. And the break means we stop executing this, and we don't execute the else statement. The else statement would report that that number is prime. It's not, and we pick it up here. Let's go ahead and execute it for a non-prime number. So let's do 10. Execute this statement. What happens is at the point that the integer divisor reaches the value of 5, 5 into 10 is exactly even, a remainder of 0. We print that it has a factor, and we break. And when we break, we skip the else and move on for saying thanks for playing. If we set it to a prime number, such as 11, when we execute this value, we go through all the divisors, 10, 9, 8, 7, 6, 5, 4, 3, 2, and none of them has a remainder of 0. So at that point, the Boolean expression becomes false. We execute the else and print that, in fact, that number is prime, and continue on saying thanks for playing.